Hello students, welcome you all for the today's lecturing session on robotics. In today's class, we are discussing with introduction regarding to the robotics, then definition of robot, then definition of robotics, then classification of robotics, then what do you mean by the work volume, then advantage, disadvantage and application of industrial robot. Okay, so very first thing we need to know how the word robot was coined. That is very much important. Okay, so the word robot was first coined in the year 1920 by the Czech novelist Karl Čapek. Okay, so according to the Czech novelist Karl Čapek, the word robot, it is nothing but it is a servant. Okay, it is just a nothing but servant, and it can be used as an artificial agent for the replacement of human labor. But actual technological development was made in the year 1957 by English inventor Cyril Walter Kenworth, and he invented a manipulator, and it can be moved in three different directions like X, Y and Z direction, and that robot was used in the industries. That's why it will become the industrial robot. Okay, so the manipulator or industrial robot, it is one and the same. It is mainly used for purpose of the industries. Okay, so that is called it as the introduction regarding to the industrial robot. Next, very important thing, it is called what is mean by the definition of robot. Okay, so what is mean by the robot? Robot is a reprogrammable, okay, it is a reprogrammable multifunctional manipulator. Okay, multifunctional manipulator that are designed to move material, parts, tools through variable programmed motion. So this is the definition of robot. So what is mean by the robot? Robot is a reprogrammable multifunctional manipulator that are designed to move material, parts, tools through variable programmed motion to perform variety of tasks. Okay, to perform variety of tasks. So the task means it may be pick and place operation. Okay, so it may be in order to transfer the component from one place to the another place, or in case of the industries, the machine loading and unloading condition, or during the spray painting operation, welding operation, then laser cutting operation. So in order to do such kind of task, we are going to use the robot. Here the robot is a reprogrammable multifunctional manipulator that are designed to move material, parts, tool through variable programmed motion to perform the variety of tasks. And the robot, it is also called it as an artificial agent, and it can be used as a substitute for human labor. So this is regarding to the robot. Then what is mean by the robotics? The robotics is a field of technology that deals with design, conception, construction, operation and application of robot. Okay, so what is mean by the robotics? Robotics, it is a field of technology. Okay, it is a field of technology that deals with design, conception, construction, operation and application of robot. Okay, so this is the definition of the robotics. So robotics is a field of technology that deals with design, conception, construction, operation and application of robot. Also, the industrial robot or a robot, it possesses human-like characteristics. Okay, the robot is nothing but it performs the human-like characteristics, and it can be used as a substitute for human labor. So that means, what are the human-like characteristics? That means it can make communication, okay, then interaction and decision making, capability to respond sensory input. Okay, capability to respond sensory input. So these are the robot can perform like the human like characteristics. Okay, so what is meant by the robotics? Robotics is a field of technology that deals with design, conception, construction, operation and application of robot, and it also performs the human like characteristics like it can think like a human, that means capability to respond sensory input. Suppose if I giving a command to transfer this component from this place to this place, it will give this, it will take the sensory input. Then communication, it will ask the command, so whether your command is right or wrong, can I transfer this component from this place to this place. Then interaction and decision making, then it will finally take the decision and make the operation and transfer the component from one place to the another place. So this is regarding to the human like characteristics. Next very important one, it is called terms related with the industrial robot. Okay, so what is mean by the industrial robot? I already told, in the year 1957 the English inventor Cyril Walter Kenward, he invented a manipulator that can be moved in all the three directions like X, Y and Z direction, and that robot was used in the industry, that's why it is called industrial robot. Then what are the main parts of the industrial robot? That is very much important. Observe here, this is the base, okay, and this is the body, and this is the joint. I will call it as joint number 1, and this is the joint, this is called joint number 2, and this is called link 1, and this is called link 2, and this is called wrist, and this is called end effector. Okay, first we need to know one by one what is mean by the link. Okay, the link is a rigid member that connects the joint, is it right? Here the link is a rigid member that connects the joint, so it provides the relative motion between the input link and the output link. That means the motion of the input link provides the various motion to the output link. Okay, so this is called as link. A link is a rigid member that connects the joint. Here the motion of the input link causes the various motion to the output link. So first thing, it is called as the link. Second one, what is mean by the joint? Okay, a joint, it integrates the links together, is it right? So joint number 2, it is integrates the link 1 and link 2. A joint, it integrates the link and it provides controlled relative motion between the link 1 and the link 2. Okay, so what is a joint? Joint, it integrates the links and it provides the controlled relative motion between the input link and output link. Next, third one, end effector. Okay, what is mean by the end effector? That is very much important. End effector, it is a tool or a gripper and it is connected to the end of the robotic arm with the help of the wrist. And this end effector, it is usually in the form of the hand or a tool in order to perform the variety of tasks based on the application. So this is called as the end effector. Next, fourth one, base. So the entire robotic arm, it is stand on the base. That means the base, it acts as the support for the robotic arm. Okay, so here the base, it acts as the support for the entire robotic arm. Next, fifth one, it is called manipulator. So what is mean by the manipulator? Here this body and this complete portion, it is called as the arm. Here the body, arm and the wrist together, it is called as the manipulator. And this manipulator, it is designed to move material, parts, tools through variable programmed motion without the direct human contact. So this is called as the manipulator. I repeat, what is the terms related to the industrial robot? Here very first one, it is called the link. A link is a rigid member that connects the joint. Here the motion of the input link gives the various motion to the output link. Then what is meant by the joint? A joint integrates the two links together. Okay, so that means it provides the controlled relative motion between the input link and output link. Then what is meant by the end effector? End effector is a tool or a gripper connected to the end of the robotic arm with the help of the wrist, okay, and this wrist are shaped like a tool or a hand based on the application. Then base, it is a support for the entire robotic arm. Then manipulator, body, arm and a wrist together, it is called as a manipulator, and this is designed to move the material, parts and the tools through variable programmed motion to perform the variety of tasks. So this is regarding to the terms related to the industrial robot. Next one, what is meant by the work volume? So work volume means it is the volume or space, it is the volume or space within which robot can operate. So this is called work volume. I repeat, what is meant by the work volume? So work volume, it is nothing but it is the volume or space within which robot can operate, that is called as the work volume. And what are the main parameters? It is very important to decide the work volume of the industrial robot. There are 4 parameters. First one, it is called size. Next, second one, it is called physical configuration. Next one, it is called limit of its arm. And fourth one, it is called joint manipulation. So this is regarding to the work volume. Okay, what is the work volume? It is the volume or a space within which robot can operate. It is called as the work volume. And the work volume of any industrial robot, it is mainly depends upon the 4 parameters. First one, it is called size. Second one, it is called physical configuration. Third one, it is called limit of its arm. Fourth one, it is called joint manipulation. Then based on the physical configuration, the robots are classified into 4 types. Okay, based on the physical classification, robots are classified into 4 types. First one, it is called Cartesian configuration robot. Second one, it is called cylindrical configuration robot. Third one, it is called polar configuration robot. And fourth one, it is called jointed arm configuration robot. Okay, so this industrial robot, whatever the figure we have written, this itself it is called jointed arm configuration robot. Okay, so this itself it is called jointed arm configuration robot. Very first one, we need to know what is meant by the Cartesian configuration robot. So in case of the Cartesian configuration robot, here motion of these kind of robot traces the rectangular workspace. Okay, here motion of these kind of robot traces the rectangular workspace. That means this is called y direction, this is called x direction, and this is called z direction. That means this kind of robot, it consists of 3 perpendicular sliding joint along x, y and z axis. Okay, observe here, this is the one joint, it is connected to the wrist, and this is the another joint, it is connected to the vertical column, and another joint it is connected to the base. Okay, so what is meant by the Cartesian configuration robot? Here motion of these kind of robots are traces the rectangular workspace. That's why it is also called as the rectilinear robot. And these robots are having the 3 perpendicular sliding joint along x, y and z direction. That's why the Cartesian configuration robot, it is also called as the x, y and z robot. Then observe the motion. These Cartesian configuration robot can be moved up or down, left or right, and front or backward side. And motion of these kind of robot can be start or stop anywhere along the x, y and z axis system. So this is called as the Cartesian configuration robot. Okay, observe here, it consists of 3 perpendicular sliding joint x, y and z, and this robot can move up or down, left or right, front or backward. And motion of this kind of robot can be start or stop anywhere along x, y and z axis. So this is called as the Cartesian configuration robot. Next, second one, what is meant by the cylindrical configuration robot? Here the motion of these kind of robot traces the cylindrical workspace. Okay, here motion of this kind of robot traces the cylindrical workspace. Then it consists of the slider. Okay, it consists of the slider in the horizontal position. Then it contains the vertical column in the vertical position. Okay, so what are the two main parts? It consists of the slider in the horizontal position and column in the vertical position. Then very much important thing, it is called here this entire arm assembly. So this complete, it is called arm assembly. This entire arm assembly can be moved up or down with the help of the Z joint. Okay, this entire arm assembly can be moved up or down with the help of the Z joint. Then this vertical column can be rotated about its own axis using the R joint. Okay, here this vertical column can be rotated about its own axis using the R joint. Next, very important one, this arm can be radially moved in and out using the X joint. Okay, so this is the configuration of cylindrical configuration robot. Okay, here the motion of these kind of robots are traces the cylindrical workspace. It contains slider in the horizontal position and column in the vertical position. That means here this entire arm assembly can be moved up or down using the Z joint. Then vertical column rotated about its own axis using the R joint. Then this arm can be moved radially in and out using the X joint. So this is called as the cylindrical configuration robot. Then third one, it is called jointed arm configuration robot. We are already discussed what are the main parts of the jointed arm configuration robot. It contains the two link, two joints, one body and the base. Okay, and the motion of these kind of robots are traced as the sphere. Okay, motion of these kind of robots are traced as the sphere. Then what is the function of the link? A link is a rigid member, okay, that connects the joint, and motion of the input link provides the various motion of the output link. Then what is a joint? A joint, it integrates the two links together to provide the controlled relative motion between the input link and output link. Then what is meant by the end effector? End effector is a tool or a gripper, and it is connected to the wrist at the end of the robotic arm, and it is designed to move material, parts and tools based on the application. Then here base, it acts as the support for the entire robotic arm. Then very important one, what is meant by the manipulator? Here the body, arm, wrist together, it is called it as the manipulator, that are designed to move material, parts and tools through variable programmed motion without direct human contact. So this is called it as the jointed arm configuration. Next we are moving on to the last one, it is called polar configuration robot. The next type, it is called polar configuration robot. So what is meant by the polar configuration robot? It is very much important. In this kind of robot, here the motion of these kind of robot traces the partial sphere. Okay, so what is meant by the polar configuration robot? Here motion of these kind of robot traces the partial sphere. That's why it is also called as the polar configuration robot. Then what are the important parts of the polar configuration robot? That is also very much important. It mainly consists of the base, vertical column, sliding arm and the pivot. Okay, so very much important thing, it is called, the four main parts are base, vertical column, sliding arm and the pivot. Then the main thing we need to observe here, it is called, here vertical column, it is mounted on the base and it is rotated about its axis using the Z joint. Okay, so this is the first point. Here the vertical column is mounted on the base and it is rotated about its own axis by using the Z joint. Then very much important one, it is called here sliding arm. Okay, here this sliding arm can be extend and retract to provide the particular reach. Okay, so this is the second one. Then very much important one, it is called here the pivot is used to rise or lower the arm. Okay, so this is the motion regarding to the polar configuration robot. Here the main thing, it is called pivot is used to rise or lower the arm. That is mainly we are going to use in the forging operation. Okay, observe here what is meant by the polar configuration robot. Here motion of this kind of robot traces the partial sphere. Okay, and here the main parts, it is called base, vertical column, sliding arm and the pivot. Very first thing, it is called here vertical column is mounted on the base and it is rotated about its own axis using the Z joint. Then sliding arm, it is extended and retract to provide the particular reach. Then pivot is used to rise or lower the arm. So this is called polar configuration robot. Okay, there are mainly 4 types. The first one, it is called Cartesian configuration robot. Here the motion of the robot, it traces the rectangular workspace. Then cylindrical configuration, here motion of the robot traces the cylindrical workspace. In case of the polar configuration, motion of the robot traces the partial sphere, and in case of the jointed arm configuration, motion of the robot traces the complete sphere. Okay, then the main parts, it is called, in case of the Cartesian configuration robot, here it consists of 3 sliding joint along x, y and z direction, and the robot can be moved anywhere along z axis, y axis and x axis, and it can be start or stop anywhere along x, y and z axis system. But in case of the cylindrical configuration robot, we are having the up and down movement, rotational movement, as well as the sliding arm can be radially moved in and out. But in case of the polar configuration robot, here sliding arm can be extended and retract to provide the particular reach, and pivot is used to rise or lower the arm, and vertical column is used to rotate about its own axis. So these are called as the different types of configuration based on the work volume. Okay, then very much important thing, it is called various types of joints we are going to use in case of the robotic arm. That is very much important. We all know that the robotic arm, it is nothing but it is an industrial robot. It performs the human-like characteristics. That means it is capability to respond sensory input, communication, interaction and decision making. And for that we need to classify into 5 types, that is called linear joint, orthogonal joint, rotational joint, revolving joint and twisting joint. That is very much important. First one, what is meant by the linear joint? Here the linear joint provides the linear motion. Okay, linear joint provides the linear motion in such a way that here the axis of the input link and axis of the output link are parallel to each other. Okay, observe here what is meant by the linear joint. The linear joint provides the linear motion. Here the axis of the input link and axis of the output link are parallel to each other. Then these kind of joints are called as the linear joint. Then what is meant by the orthogonal joint? That is very much important. So the orthogonal joint provides the linear sliding motion. Okay, it provides the linear sliding motion, and very much important thing, it is called, here the axis of the input link and axis of the output link are perpendicular to each other. Okay, here the axis of the input link and output link are parallel to each other, but here axis of the input link and output link are perpendicular to each other. Then it is called as the orthogonal joint. Then what is meant by the rotational joint? That is very much important. So linear joint and orthogonal joint mainly it is used to obtain the linear motion, but the rotational joint, it's mainly used to obtain the rotary motion. Okay, it is mainly used to obtain the rotary motion in such a way that, very important thing, it is called, here the axis of rotation, here the axis of rotation, axis of rotation is perpendicular to the input link and output link. Okay, so this is very much important. What happens in case of the rotational joint? It provides the rotary motion, and very much important thing, it is called, the axis of rotation is perpendicular to the input link and output link. Then what is meant by the revolving joint? Okay, so the revolving joint is also provides the rotary motion. Okay, revolving joint is also provides the rotary motion. Here axis of rotation for the input link is parallel, and axis of rotation for the output link, it is perpendicular. Okay, observe here. So this is the parallel direction and this is the perpendicular direction. That means here the axis of rotation for the input link is parallel and the axis of rotation for the output link, it is perpendicular. Then this is called as the revolving joint. Then what is meant by the twisting joint? So this twisting joint is also produce the rotary motion, but here the axis of rotation for the input link and the output link are parallel to each other. Okay, so twisting motion, normally we can observe the accelerator in the bike. Okay, so here we are obtaining the twisting motion, but the axis of rotation for the input link and output link are parallel to each other. So this is regarding to the 5 types of joints what we are going to use in case of the industrial robot. I repeat, what is meant by the linear joint? The linear joint provides the linear motion. Here axis of the input link and output link are parallel to each other. Next, orthogonal joint. The orthogonal joint provides the linear sliding motion. That means your axis of the input link and output link are perpendicular to each other. Then rotational joint. So rotational joint provides the rotary motion. That means here the axis of rotation is perpendicular to the input link and output link. Then revolving joint. The revolving joint also provides the rotary motion. Here the axis of rotation for the input link is parallel and axis of rotation for the output link is perpendicular. Then last one, twisting joint. Here the axis of rotation for the input link and output link is parallel to each other. So this is regarding to the various types of joints we are going to use in the industrial robot. Next, last very important thing, it is called advantages, disadvantages and application of industrial robot. So what is the main advantages with the help of industrial robot? Very first thing, it is called, it increases productivity. Okay, it increases productivity of the operation. Then increases consistency and quality of the product. Increases consistency and quality of the product. Then it provides safety of the operation. Okay, industrial robots can provide safety of the operation. Then it can also work in the hazardous areas. Okay, it can also used in the hazardous areas where human labor cannot operate. Okay, next, it can work continuously. It can work continuously without facing fatigue problem. Without facing fatigue problem. Then it can perform multiple tasks simultaneously. Multiple tasks simultaneously. Then very much important one, it is called, it produces less defective parts. Okay, it produces less defective parts. Next, last one, it is called, it can be used as substitute. It can be used as substitute for human labor. Okay, it can be used as a substitute for human labor. So these are some of the advantages of the industrial robot. First one, it increases the productivity of the operation. Then it increases the consistency and quality of the product. Why? Because in case of the human error, so because of that, so consistency and quality of the product is coming down from time to time. But it also provides the safety of the operator. That means even the hazardous area can be operated with the help of the industrial robot. Then it can work continuously without facing any fatigue problem. Multiple tasks can be performed. Then it produces less defective parts. Then it can be used as a substitute for human labor. Then what are the disadvantages? High initial investment. Okay, high initial investment is needed for the industrial robot and its operation. Then high maintenance cost. Okay, high maintenance cost is required. Then in order to operate the industrial robot, power supply is essential. Okay, power supply is essential. Then good program capability or good programmer and computers are necessary to operate the industrial robot. And last one, it increases unemployment. Okay, that means it reduces the opportunity of human labor. Okay, so some of the disadvantages is called high initial investment, high maintenance cost is also required, then power supply is essential to operate the industrial robot, good programmer and computers are necessary, and it increases the problem of unemployment. Okay, then applications. So very first thing, it is called hazardous areas. Industrial robot can be operated in the hazardous areas like spray painting, laser cutting and welding operations. Okay, so some of the hazardous areas like spray painting, laser cutting and welding, the industrial robot can be used. Then material handling. So for material handling like pick and place operation and machine loading and unloading condition. Okay, machine loading and unloading, we can use the industrial robot. So dangerous areas like nuclear power plant, thermal power plant and atomic research center. Then difficulty in handling like forging, heat treatment operation as well as in the cryogenic and refrigerating condition. Then other areas like agricultural sector as well as the constructional sector, we are going to use the industrial robot. Then we can also use in the processing and assembly operation also, we can be use the industrial robot. So that means like some of the car companies like Benz, Audi, all are nowadays for the processing and assembly operation we are using with the industrial robot. Okay, so some of the areas like hazardous areas like spray painting, laser cutting and welding. Then material handling like pick and place operation, machine loading and unloading condition. Then dangerous areas like nuclear power plant, thermal power plant as well as in the atomic research center. Then difficulty in handling like forging operation as well as in the heat treatment operation. Then other areas like agricultural sector and constructional field also we can use with the industrial robot. Okay, so this completes the robotics and work volume classification, advantage, disadvantage and application of industrial robot. Thank you.